Okay, so this little video is about refraction and Snell's law. So refraction is where we have the bending of light as it enters a new medium. Okay, so simply the light is going to be diverted off its path as it goes across a boundary into a new medium. Now we've got two different possibilities that it could be going from here. It could be going from a less optically dense medium into a more optically dense medium, or it can be going from a more dense medium into a less optically dense medium. So I've got the two different situations here. So if I'm looking at this, and let's say it's going from a less dense medium to a more dense medium. As it goes into a more dense medium, okay, it's going to slow down. So that's the first thing, is it's going to slow down, and that means that it's going to bend and turn, and it's going to turn towards the normal line. Okay, so if it's going from a less dense to a more dense medium, we know that its speed is going to decrease. Okay, and also therefore it's going to, what was I saying there? Its angle of refraction is going to get small. It's going to bend towards, so it's going to bend towards the normal. Okay, and what that means is that my angle of refraction is going to be less than my angle of incidence. Okay, so my angle of incidence is going to be greater than my angle of refraction, which we can see here. So it's slowing down and bending towards the normal. If it's going though from a more dense medium to a less dense medium, it's going to do the opposite. Its velocity, the speed of the wave in this case, is going to speed up because it's going from a less optically dense medium. It can travel faster. So this means that at this time it doesn't bend towards it, it's going to speed up and move away from the normal. So it bends away from the normal. Okay, so in this case, the angle of refraction is greater than our angle of incidence. Now we can sum all this up kind of mathematically as well by using an equation called Snell's law. So Snell's law is an equation where we might talk about the different mediums. So the measurement of those mediums and how optically dense they are given by something called the refractive index. Okay, so the refractive index is a known number. We start off with air and a vacuum, which we count as 1, and then we have different materials have different refractive indexes. So glass and water have a different one. We compare them in relative terms to air, so we class air as 1 and then use those from kind of there onwards. You do need to know that air in a vacuum is given as 1, but all the others would be given to you in a question. So Snell's law is given by the equation sine theta 1 divided by sine theta 2. Now 1 and 2 just corresponds to the different mediums, so medium 1 and medium 2. Now they are equal to the refractive index of 2 divided by the refractive index of 1. That is also equal to the velocity, so we also have the velocity of 1 divided by the velocity of 2. And if in that case we can also link it, because V is equal to F lambda, we can also say that it's also lambda 1 over lambda 2 as well. So we can also do refraction. We could talk about it in terms of its wavelength as it goes through. I should have said that as well. As it goes in, its wavelength also decreases, and its wavelength over here also increases. And then you might be saying, well, what about the frequency? The frequency stays the same. Okay, if I had 5 waves approaching, I would still have 5 waves entering. Okay, so it's simply the wavelength and the speed of them that change. Again, if I had 5 waves entering, so 5 waves coming in, I'd still have 5 waves appearing into my medium. So that's just a simple one with this equation. So little things to watch out for. Okay, just remember to take the sine of the angle. Okay, so make sure your calculator is in degrees. All right, so make sure you're checking out for that one. And then here, okay, just remember it's a flip, so all these are 1 over 2, 1 over 2, 1 over 2, but the refractive index is the other way round. And just remember that n is equal to 1 in air and a vacuum. Okay, so that is given, though it's not given to you, you would be expected to know that. And that is a little bit on Snell's law. So there you go.